Yes, let's continue about the we are discussing the topic solid state, and now in the current lecture we are going to see about the types of crystalline solids. Crystalline solids are of the four types. Here I'll write first heading, what are the types of crystalline crystalline solids. Okay, so crystalline solids are either molecular solids, ionic solids, covalent solids, or the metallic solids. So these are the four types of the crystalline solids. Okay, if feasible, you can make a notes of these things. Now let's see the properties of each one. Okay, so firstly I am going to explain molecular crystalline solid. Okay, so these crystalline solids, these are also known as the ideal solids. Okay, and the first type is here, that is molecular crystalline solids, or only molecular solids also we can write. With the help of some points I am going to explain. That first point is what? That is nothing but the constituents. Okay, constituents. Then after the constituents, which interparticle forces of attraction are there. The next one, intraparticle forces of attraction. Okay, intraparticle forces of attraction is nothing but the which type of the chemical bond is present in these types of solids. Okay, now beside this, what about their physical state? Of course, all these are the solid, we are discussing the solid. Physical state is solid, but soft, hard, very soft, very hard, like that we are going to use the terms. What about their melting points? And next one will be the examples. Okay, so let's begin. First type of the crystalline solid, its properties. First one, that are the molecular solids. What is the first property of the molecular solids? What are the constituents? Constituents of the molecular solids are molecules. Okay, and before continuing, let me tell you, these molecular solids are of the three subtypes. Which one? Molecular solids are either polar molecular solids or non-polar molecular solids, and last one, hydrogen bonded molecular solids. And these hydrogen bonded molecular solids are also called as hydrogen bonded polar molecular solids. Clear? So molecular solid, there are three types here, these are written. Now I'll start with the example. Firstly, what is the example of the polar molecular solid? Polar molecular solid examples are sulfur dioxide, sulfur trioxide, carbon monoxide. Okay, so if the electronegativity difference is more, then one of the atom will carries partial negative charge, another will carries partial positive charge, and that negative positive charge difference is more, so we call such a molecule as a polar molecule. So here sulfur and oxygen is more electronegative. Okay, here carbon and oxygen is more electronegative, carbon is less electronegative, so oxygen will carries partial negative charge, here carbon is going to have a partial positive charge, and that's why one carbon monoxide molecule, suppose here another carbon monoxide molecule, here also the same story. Okay, so the negative end of the one carbon monoxide molecule and positive end of the another carbon monoxide molecule, there is a certain force of attraction. Here we call it as a interparticle force of attraction. Okay, one carbon monoxide molecule, another carbon monoxide molecule, in between them. Okay, that is the interparticle force of attraction. And here we call it as a, that is nothing but the dipole interaction. Okay, dipole interaction, that is the intermolecular or interparticle force of attraction. Yes. Now the next one, what is the intraparticle force of attraction? Which chemical bond is there? So in between carbon and oxygen, there is a triple covalent bond. Okay, so Students, are you understanding? We are discussing about the polar molecular solid. First property of the polar molecular solid is their constituents are molecules. Molecules, CULES. Second property, dipole-dipole interaction is there. What is the meaning of dipole? Dipole means polar molecule. This is one polar molecule, this is the polar molecule, and in between them there is an interaction, dipole-dipole interaction, that is interparticle force. What is the intraparticle force of attraction? Means which chemical bond is there in between carbon and oxygen, that we call it as a covalent bond. Okay, so carbon shares electrons with oxygen, oxygen shares electron with the carbon. I'll draw the structure. Carbon having 4 electron in the valence shell, oxygen having 6 electrons in the valence shell. Oxygen electron I am showing by the sign cross. So in between carbon and oxygen, here 3 electron pairs are get shared. Okay, 2 electrons of the carbon, 4 electrons are of the oxygen. So triple bond is there in between. So the bond which is formed by the mutual sharing of electron, that is the covalent bond. Okay. Now what about the physical state of the polar molecular solids? So polar molecular solids, of course they are solid. Here they are the soft solids. What about their melting points? They have the low melting points, and here the examples are given. Now let's see non-polar molecular solids. Okay, non-polar crystalline molecular solids, constituents, molecules, interparticle. Before seeing these properties, let's see the example of the non-polar molecular solids. Non-polar molecular solids examples are which one? I2, F2, Cl2, Br2, H2. These are the examples of the non-polar molecules. Okay, so non-polar molecular solids. You know that at room temperature, H2, Cl2, these are the gaseous one. But we are talking when these substances are get gasified. Okay, sorry, when these gaseous substances are get liquefied and afterwards solidified at a very low temperature after compression. So in the solid state, suppose we have these substances, so we call them as a non-polar molecular solids. Now what is the interparticle force of attraction? Just imagine, here we have, okay, here we have one iodine molecule, here we have the another iodine molecule. It is non-polar molecule. Okay, non-polar means what? Iodine and here iodine. In between two iodine atoms, two electrons are get shared. Correct? So we can't say that electron is shifted more toward this iodine or this iodine. No, of course it is a I guess that some of you may know the non-polar means what, some may do not know. So that's why I am explaining. Non-polar molecules means what? The electron pairs between the constituent atoms is not get shifted towards any of the specific atom. That electron pair is get equally distributed. In between two iodine atoms, electron pair is equally distributed. In between the two fluorine atoms, so the electron pair is equally distributed. So that is the non-polar molecule. We can't say one of the fluorine is more electronegative, another is less electronegative. We can't say. So here such a say for example only iodine we have. So in between two iodine atoms there is a certain force of attraction. Okay, that is not a chemical bond, but we call it as a that is the London force, or that is the dispersion force, or which is also known as the van der Waals force of attraction. Okay, Fritz London was a scientist, and in 1932 he stated about the existence of such a physical forces of attractions. Okay, that's the London forces. These are also known as the dispersion forces. Van der Waals also stated the existence of these forces, that are also known as the van der Waals forces. Okay, now what about the intraparticle force of attraction? Let's see. Intra means what? Chemical bond in between two iodine atoms. Which force of attraction is here? Of course it is a covalent bond. Okay, now what about the physical state? These are very soft. Okay, I hope you can guess that iodine and that iodine in liquid state at a room temperature, or that chlorine, hydrogen, these are the gases at room temperature, and when we solidify them, so we have to compress them, we have to decrease the temperature. Okay, and the interparticle force of attraction is very weak one. Okay, naturally they want to be that hydrogen chlorine they want to be gasified. So that's why they have they are very soft one. In solid state they are very soft one, and their melting points are very less. They have the very less melting points. I gave here examples: I2, Cl2, F2, N2, O2. Okay, in solid state, of course, we are talking about the solids. Now, last one, hydrogen bonded molecular solids. What are the hydrogen bonded molecular solids? So, example firstly, I'll write HCl, H2O, HF, NH3, H3BO3. These are the examples, some examples of the hydrogen bonded molecular solids. Okay. Now, here in this case, say for example, this is one HCl molecule, this is another HCl molecule. In case of HCl, chlorine is more electronegative. In between hydrogen and chlorine, there is an electron pair, and that electron pair is get shifted towards the chlorine. So chlorine will carry partial negative charge, correct? And hydrogen will carry the partial positive charge. Same is the story of the another hydrochloric HCl molecule, hydrochloric acid molecule. So this chlorine partial negative, this hydrogen partial positive charge. There are millions of HCl molecules. Okay, if we took some 100 ml, 200 ml of the HCl, so millions of the HCl molecules are there. So in between one HCl and another HCl, there is a certain force of attraction. Okay, of course, that's the interparticle force of attraction that you understood. Here, that interparticle force of attraction, which interparticle force of attraction? That is dipole-dipole interaction, because it is one polar molecule, it is another polar molecule. It is dipole-dipole interaction. But more specifically, when these polar molecules are having certain interparticle force of attraction, and one of the constituting atom in the polar molecule is hydrogen. If one of the constituting atom is hydrogen, we call it as a hydrogen bond. So here the interparticle force of attraction is hydrogen bond. And which force of attraction is there in between hydrogen and chlorine? In between hydrogen and chlorine, there is a covalent bond. And what about the physical state? Comparatively, they are hard in nature. Okay, they are comparatively hard as compared to the polar and non-polar molecular solids. They are the hard one, ice. Okay, and beside that, they are hard in nature, and they are having very low melting point. In this case is also low. I am not going to say they are having the high melting point. No, they are having the low melting point. But here comparatively, किससे कंपेयर कर रहे हैं? We are comparing with the polar and non-polar molecular solids. They are hard in nature. But if we compare hydrogen bonded molecular solid with the metallic solid or covalent solid, then they are the soft one. Okay. So this is about the first one, molecular solids. Okay, better I'll finish the remaining things fastly. Here first type we discussed molecular solids. Second type of the crystalline solids. Now further there are the subtypes. Okay, directly we'll get the things. Second one, that is nothing but after the molecular solids, second type of the solids, that is nothing but I'll write here. Second one, ionic solids. Ionic solids. What are the constituents of ionic solids? Ions are the constituents of the ionic solids. Here interparticle and intraparticle, both the forces are ionic bond, which is also known as the electrovalent bond. Okay. Here what about their physical state? They are said to be very hard and they are brittle. Okay. And what about their melting points? They have the very high melting point. Okay. And examples: NaCl, KCl, KBr, okay, KNO3, and so on. Many other examples: NH4Cl, that first or second group metal, and group number 16, 17 non-metal combined together to form the ionic compounds. Okay. So here, say for example NaCl. In case of NaCl, Na plus is surrounded by the 6 Cl minus ions. Correct. This upside, downside. left, right. Here backside Cl minus and front side Cl minus. This Cl minus is get surrounded by the 6 Na plus ions, Na plus, Na plus, top, bottom, left, right. Here backside Na plus and front side Na plus, and like that here there is a 3-dimensional structure. Millions of the Na plus and Cl minus ions are there. Okay, so in between Na plus and Cl minus there is a ionic bond, and there is a no existence of we can't say this is NaCl, another NaCl. No, hope that you understood. There is a no interparticle forces of attraction. All forces of attractions are the ionic or electrovalent bond. Okay, next one, that is here the things are written, easy one it is. Next one is after the ionic solids. Next type of the solids are covalent solids. Okay, third type of the solids are the covalent solids. What are the constituents of the covalent solids? Here also the constituents are molecules. Okay, in the first case we have seen molecular solid constituent molecules, covalent solid constituents are molecules. Okay, sometimes the constituents may be atoms also. Okay, that examples we will see. Interparticle forces of attraction and intraparticle forces of attraction, both are the covalent bonds. Okay, bond which is formed by the equal sharing of electrons, mutual sharing of electrons. Okay, that's the covalent bond. And here the physical state, they are very hard. Okay, and here melting point is also, they have generally high melting points, very high melting points. Okay, here I'll make physical state soft to hard. Okay, generally they are, most of them are very hard. I'll write here soft in bracket and hard, they are very hard. Soft example graphite, but in remaining all cases they are the hard. Examples, covalent solid examples, graphite, diamond, okay, silicon carbide, sulfur, phosphorus. These are the examples of these solids. Now students, for example, if we took example of a graphite, one carbon atom central, another carbon atom, it is connected to the 4 other carbon atoms. So this carbon is also connected to the 4 other carbon atoms. Okay, what we are noticing, all bonds are the covalent bonds. Please try to understand the difference. In molecular solids, there is a presence of covalent bond. Intraparticle force, covalent bond, here also covalent bond. But in case of the molecular solid first, which we have discussed, there is a interparticle force of attraction. Okay, so here all bonds are the covalent bonds. Even in silicon carbide, SiC, silicon carbon, each silicon is connected to the 4 carbon atoms. Each carbon is connected to the 4 silicon atoms. Okay, so all are the covalent bonds. Interparticle force of attraction doesn't exist. All forces of attractions are the covalent bonds. That is the difference. The remaining things are written here. There may be a little debate about the physical state. So some of them are soft, like a graphite. Okay, some allotropes of the sulfur, phosphorus, they are also soft one. You should take it as soft to very hard and make underline to the very hard. Okay, generally they are very hard with the very high melting points. And the last one, the metallic solids, last point I am writing here, that is the metallic, A, B, C, D, that is the metallic solids. These, hope that you understood, these points are going to remain same, and remaining another part only we are changing here, means what are the constituents, interparticle forces and all that. So in case of the metallic solids, the constituents are what? The constituents are metallic ions surrounded by the sea of electrons. Suppose here we have the metallic ion, that is Fe+2, and it is surrounded by the sea of electrons. Fe+2 surrounded by the sea of electrons. Okay, Then constituents, metallic ions surrounded by sea of electrons. Next one, interparticle forces of attraction and intraparticle forces of attraction. All are the metallic bonds. Metallic bonds. What is the metallic bond? The force of attraction in between the positively charged metallic ion and the sea of electrons in the three-dimensional network crystal structure of the metals is called as the metallic bond. Okay. Then next one, physical state. They are very hard. Okay, they are very hard. Then what about their melting points? Melting points are low to high. We have the solid like a mercury. Okay, we have the solid like aluminum, copper, iron. Mercury melting point minus 38.3 degrees Celsius, aluminum 660 degrees Celsius. Okay, copper 100 and 1084, iron 1535 degrees Celsius. So some of them having very low, even metal like bismuth, they are having the melting point low. So low to high, generally metals having the high melting points, some having the low melting point. You should write low to high. Okay, now examples are here in front of you. Mercury and all these are in the solid state. Okay, mercury we know it is in liquid state at a room temperature, but we are talking about the metallic solid. So mercury, if we freeze below minus 38.3 degrees Celsius, it will be a solid one. Okay, so in the current lecture we discussed that crystalline solids are of the four types, that are molecular, ionic, covalent and metallic. And molecular solids are further classified as polar molecular, non-polar molecular and hydrogen bonded molecular solids. And with respect to the constituents, interparticle forces, intraparticle forces of attractions, their physical state, melting point and corresponding examples. Okay, here I tried to explain these properties. Okay, thank you for keeping the patience and watching this. Okay, bye.